posed or not? It is the question. Now, here my point is actually what do you mean by well-posed problem? How we are going to inference these medical problems in as a well-posed problem? That is my discussion. Now, let us take well-posed problem in the sense. Let us take any one task. Now, if I want to calculate the performance of the task, now let us take the performance of the task is increasing according to its experience. Increasing performance of the task with respect to the experience. That behavior, any problem which have this behavior, we call as well-posed problem. Okay, a task increasing its performance with its experience, we call as well-posed problem. Okay, it is general definition. But if I discuss one healthcare problem, whether this comes under this category or not, that is the question. For example, I have a problem like this. I have some experience, in this. Here, experience in the sense it's nothing but your data set. You have a knowledge in the sense data set. You have a data set. For example, I have taken only 4 records. I have taken. Let us take. This is my 4 records. 4 records I have taken. With my these 4 records, I developed a model. I have designed a model, and I'm going to test this model with one test data. Okay, but this model may be applicable for these 4 records, designed from these 4 records, tested with the real world data. Naturally, it won't give the correct answer. Why? Because your model is on developed by only 4 records. 4 records is in the sense your knowledge is very less, only 4 records. Okay. Now, if I increase this model, this data set, let us take, I have taken 1,000 records of that data set and 1,000 fields I have taken, dimensions I have taken, features I have taken. That means what? I'm going to increase my knowledge. Okay. I'm increasing my data set in the sense, what do you mean? I'm increasing my knowledge. If I'm going to increase the knowledge in this with what you are going to get it by experience. Okay. If I'm going to increase my knowledge with this increment of knowledge, if I developed any one model, if I test this model in the real world, you may get good answer. That means what? The performance of the model is increasing. Performance of the model or task is increasing with respect to your experience. Okay, that's why whatever the problem under healthcare and which we are going to solve by machine learning, that is correctly based on well-posed problem. That falls under well-posed problem. Are you clear point here? That's why we are going to apply the machine learning algorithms. We can apply machine learning algorithms this type of healthcare problems. Okay, this is one point. And next point is, for example, there we have, for example, if there is a there we have according to your input, whatever the thing is there, your input is, let us take a relational data set, relational database or CSV files, or your input is images. According to your input, that means whether your input is relational database or CSV files, or whether your input is images, whatever you are going to do the analysis on the healthcare, that is decided which domain you are working. Okay, the domain of working in the healthcare is decided by using by your input. That means whether you have taken related relation database, CSV files, or images. According to this, you have to act and you have to decide, you have to apply the domain. Okay, this point also you please keep in your mind. Then, then I'll move to the what are the types of algorithms, what are the machine learning algorithms, all these things you know spell. Being a teacher, you know spell. What are the unsupervised, what are the supervised, what are these algorithms, all these things you know spell. But here we are going to concentrate the supervised algorithm, especially the regression. Okay, that is logistic regression I'm going to use it. This logistic regression we are going to use for the classification. Okay. This logistic regression I'm using now. I'm going to discuss, and naive-based algorithm we are going to discuss now. Okay. With this, how we are going to implement the same thing into real world application we'll discuss. Okay. Then come to here, these are the machine learning for healthcare. These are the pillars of machine learning. For example, where we are going to use this in healthcare. Then we have, as well, especially in analysis of radiology. This is very, very bad. That means medical image. Okay. Now we are going to, nowadays, we are going to use the recording. That means the smooth, smart health records. Okay. Then behavioral of modifications and data collection, clinical testing and radiography, radiotherapy, all these many applications are there which we are going to use machine learning in healthcare sector. Okay, I'm not going to concentrate all these areas. I'll now come to here once you see this figure, so that how it is developed, the machine learning applications in healthcare. In 2008, we are using our records, all records in US. Let us take the data of US. They maintain only 9.4% of data in 2008. If you see in 2015, 83.8% of data they're maintaining in the records by using ML algorithms. Okay, that's why this is the importance of machine learning in healthcare. Okay, now once you see here, what are the analytics we have? Actually, there we have, for example, you have a data set. Let us say, if you have a data set, in this data set, then what are the things that you are going to find it? Okay, here there we in data analytics there we have three parts. One is descriptive and predictive and prescriptive. Now our aim is to discuss about predictive. And descriptive in the sense it is going to discuss about the internal behavior of the data set. That is like your standard deviation, mode, mean, all these things it is going to discuss in the descriptive analytics. Okay. Now in predictive, we are going to find one forecasting of the from the existing data. We are going to define one forecasting issues. We are going to develop one forecasting models that is predictive. And in case of prescriptive, here what we are going to do here is I'm going to optimize the models. Okay, already forecasting models are there. These forecasting models, I'm going to optimize it. That is there in prescriptive. Now here our organizers they assign to me to discuss about predictive algorithms, predictive analytics. Are you clear my point? Then now also see here, what are the principles behind the predictive analytics? Not only predictive analytics, in ML algorithms, there we have two types of principles. One is parametric and non-parametric. In parametric algorithms, actually, ML algorithms we can divide into supervised, unsupervised, semi-supervised like that. And also we can divide that ML algorithms into parametric algorithms, non-parametric algorithms. These parametric algorithms, there we have a one relationship, mathematical relationship that we are going to represent. Okay. Finally, by taking one data set, I'm going to develop a model in the sense one equation, one mathematical relationship that I'm going to develop in the parametrical model. Okay. Now, even though what we are going to discuss, this logistic regression and your simple linear regression and your multiple linear regression, all this comes under parametric only. Okay. Now come to the non-parametric in the sense here we are not going to develop any one mathematical model. We are going to compute the or simulate the model. Okay, we are going to solve the problem. That means here you may take here, let us take here simulation or neural networks you can use, and decision trees, you can use random forest. All these comes under the non-parametric. Okay, now what we are discussing here, that logistic regression comes under the parametric. Okay, now come to the Next point is here, what are the model, how you are going to develop the model that you know as well. First, we are going to take the CSV file that you know as well. CSV file will take, and I already told you here, while for your input, if there is a CSV file, that domain is different. That comes under data mining and purely ML. Then if your input is images, that goes to deep learning and transfer learning, all this comes under here. Are you clear my point? According to input, your this deep learning you cannot apply for CSV files. And also this machine learning we can apply for images. How can we apply in machine learning? Actually, machine learning are the predefined models. Okay, predefined models. We required one numerical values. Okay, these, for example, if your input is image, that you have to extract the features and transform into numbers or digits. Okay, then you have to apply the ML algorithms. Are you clear my point? What I'm saying? In images, first you have to apply logic on these images, and you have to extract the features of the image, and these features you may convert into some like one numeric values. On this you can apply your ML, machine learning algorithm. Why? Because machine learning algorithms are the predefined models. Okay. Now this deep learning we cannot apply on CSV files. This point please keep in your mind. Then here, now here we are going to divide the data set into trained data set and test data set. And this is 0.2 percentage, sorry, 20 percentage, and this is 80 percentage. You're going to divide that, and we are going to, you have to apply this trained data set to model, and you have to design a model, and you have to test with the test data set. And after that, you have to evaluate the model. This is a sequence or flowchart of developing a model, prediction model. Okay. Now, once you see here, in come to the one prediction model. Here, I'm going to discuss in depth of this logistic regression mathematical model here. And after that, I'll discuss the mathematical model of the Bayes theorem. Okay. Now come to here, in logistic regression. Actually, what exactly this is a different from the linear regression that also I'll discuss. Logistic regression is a supervised learning. That means what? The data set which have the label. That means there we have data set, we can divide the features, we can divide into two categories. One is, this is x1 and x2, and this is x3, and this is y. This x1, x2, x3, this we call as independent variables. Okay, and this y we call as dependent variable. The data set which have the dependent variable, this data set we call as labeled data set. If there is a label, if there is a independent variable in the data set, this data set we are going to use in supervised learning. This dependent value will guide you in the designing a model. That's why this we call as supervised learning. Okay. Now come to here. Now this is this logistic regression. This logistic regression, it also we call as, this is a classified model, classification model. It is not a prediction model. It is not a regression model. It is a classification model. Why? Why? Because in dependent variable, this dependent variable according to this y, if there is only two values are there, either 0 or 1, this classification we call as binary classification. Actually, before going to this, actually, what do you mean by classification? What is the prediction? I'll discuss about classification in the sense here, assigning a label for object, assigning a label to object we call as classification. Okay. Now, with given data, I'm going to define a model, design a model. This model will assign a label to test data, test object. Okay, that we call as classification. Okay, now here the label is two values are there, let us take 0 or 1 or fail or pass, something is there. If there is two values are there, this classification we call as binary classification. Okay. Now here, once you see this, how it is going to work and how it is going to see that, I'll explain here. Now, how this entire this will be applied in mathematical and in the real world application. Then what are the types of logistic regression? Actually, according to your label, that means here I told you know this is the x1, x1, x2, x3, then this is y. Okay, this we call as label and this we call as dependent variable. If your dependent variable have only 0 or 1, in that case, this we call as binomial logistic regression.
See, right now, nine.
Now, here let us take this y is more than these two values. In that case, for example, cat, dog, something is there in y label, more than two values that we call as a multinomial. If it is representing an order, a meaningful sequence that we call as ordinal. That's why, according to this y dependent variable, your logistic regression have three types. One is binomial and multinomial and ordinal. Here I'm going to discuss the binomial. Okay. Now come to the next point. Then how you are going to solve this problem. Here I'm going to use one. Actually, once you see this here, let us take this is my data set. My data set is it looks like this. For example, my data set is let us take this is my x value and this is my y value. Let us take x and y. I have taken only one independent variable. Let us take this is fever. Fever is my test data. Let us take. According to this fever, whether you are positive COVID or negative COVID, let us take. COVID is over, but I have taken one example. Okay, according to your fever, whether you got the positive COVID or negative COVID. Okay, let us take my fever is 50 centigrade something, and it is positive COVID. Let us take sorry 98 some 101 degrees something, it is positive. 94 something, it is negative. Then 105, it is positive. 103, it is positive. Something. This is x value, independent variable, and this is a variable. Now here in my label, what we have here, my label is only two values. One is plus and minus. Okay, one is plus and minus. Let us take this plus is equal to 1 and this minus is equal to 0. Okay. Now, if I represent this y is 0 and 1. This is 0, this is 0, and this is 1. Let us take. This is my y-axis. Okay, label. For my x, what happened once you see this? This is x-axis. And here, if I taken my fever is so and so something, some 50, 80 degrees centigrade like this. Here it looks like this, and here it looks like this. Okay. Now here that means it is near to zero only. For example, 80 degrees. This is a y value. Okay. Now this is a y value. Okay. Now here let us take here if you are crossing your 94 degrees, 105 degrees, it is reaching to this value. Let us take. This is 105 degrees and this is 103 degrees. Let us take. Now, what happens for this 90 or 80 degrees something, you are at this place according to your linear regression model. According to your linear regression model, what you may get? You may get the equation is y is equal to beta naught plus beta 1 x. Okay, y is equal to beta naught and beta 1 x. According to this beta naught and beta 1 x, what you may get your y value you may get here 0.2 something. Let us take here your y value you may get here 0.3 something, and here you may get this is a 0.5. Let us take, and this is your 0.7. Let us take. Now by this what happens, Simply linear regression model will give you the number, will give you y is equal to zero point 0.2, the given. With this zero point 0.2, can I see that whether your fever is so and so, you are not, you are not falls under corona like that? No, it is not possible. That's why this linear regression, simple linear regression, will not solve this problem. Are you clear my point? What I'm saying? Actually, with this, what happens if I generate a simple linear regression with the x and y, it may gives like this is a line. This line represents simple linear regression. Okay, with this simple linear regression, you may get one value. Let us take for this temperature. For this temperature, you got this point. This point is it is representing zero point 0.2. That means your value is equal to y is equal to zero point 0.2. If your y is equal to zero point 0.2 in the sense whether it is representing positive corona or negative corona, it is not possible. We cannot predict positive like this. Okay. We are unable to say that whether this is positive or negative. Okay. Are you clear my point? This that means what? What my point is with the linear relationship, we are able to say that we are able to classify that whether the x is equal to 85 degrees fever falls under corona or not falls under corona. We are able to share that. What we have to do for this? That is the question. In that case, what happens? You have to design a model. That model, it represents a sigmoid function. This function we call as sigmoid function. Then with this sigmoid function, the nature of sigmoid function is it will gives you whatever value you gives you, it may gives either 0 or 1. Okay, this we require. If you know whether this is 0 or 1, you can decide that whether that person falls under corona or not. Otherwise, you are unable to decide it. That's why whatever you got this with the linear equation, whatever the value you got it, with this value, by applying this sigmoidic function, you are going to decide that whether this is near to 0 or whether this is comes under 1. Okay, that is the behavior of the logistic regression. Okay, are you clear my point? What I'm saying now? Now also see here. The finally, if I see if I see that it looks like this. For example, for my points, let us take these are my features. These are my features. For these features, if I construct a relation between these features with my label, I'm going to get a linear model. I told you, just now I told for example, this is your x and this is your y. With this x and y, you are going to get one real linear model. Linear model in the sense linear regression. You are going to get linear regression model. Okay. With that, you are able to solve this. That's why what you are going to get here is just now I discussed y is equal to you may get zero point 0.2. In that case, whether it falls under corona or not, it is not possible to know this. That's why all these y values I'm going to take into a probabilities. Okay. On these probabilities, I'm going to apply sigmoid function. Okay. With this sigmoid, I told the sigmoid function will tell you whether it is equal to 0 or 1. From this sigmoid function, you may get the 0 or 1 or 1 or 0, whatever. With this 0 or 1, whether this person falls under corona positive or negative. Like that, you are going to define. This is the background of the mathematical model. Okay. Now it is nothing but this. For example, this. If I use this, it is nothing but linear equation. x1 w1 plus x2 w2 plus x3 w3 like that you will get. This is nothing but linear equation. Okay. Plus b is the bias. Okay. If I apply on this, if I apply the logistic regression, you may get the answer either 0 or 1. Okay, so that with this 0 and 1, we can decide that this person falls under corona or not. Okay, right. Now come to the what mathematics behind this. Once you see here, actually, I told you, just now I told you, this is the line equation. This is a line equation with x and y. With this data set, you got here, this is a x and this is y. With this data set, I got this linear model. This linear model is equal to y is equal beta naught plus beta 1 x1 x. Let us take. This is a linear model. With this linear model, I'm not going to solve it. That's why I'm applying here a logistic regression model. That is logistic model. This is by using sigmoidal function. My sigmoidal function is equal, P is equal, or P of Z is equal to 1 by 1 plus e to the power of minus Z. Okay. Now, if I take this is equal to Z, now what happens here? P of Z is equal to Z or Y, whatever you may take. Z is equal to what happens? 1 by 1 plus 1 by e to the power of Z. Okay. It is nothing but e to the power of Z by e to the power of Z plus 1. Okay. Finally, you may get like this. But what is this Z? Z is nothing but linear equation. Okay, that linear equation is beta naught plus beta 1 into x. This is a z. Okay, the equation of this sigmoidal function is this. That is nothing but if I take here what happens, this z value, if I take this is equal to y, okay, you can take z or y, this is a y, then this y value have only two values. One is 0 and one is 1. For this p of the function y is equal to 1. In y is equal to 1, what you may get? E to the power of z plus 1 plus e to the power of z. If I apply, what is the z value here? Z value is nothing but I told you now, beta naught, beta 1, x1, beta 2, x2, beta x, something, something, you may get it. Okay, according to number of features. How many features are there? According to there we have the slopes. Okay, now what my point is, now here, how can you develop this model? That is the question. The question is what? How can you develop this model? Developing model is something but generating equation. Generating equation is nothing but, for example, here in this equation, for example, let us take this is your equation, your pi, your what happens here, your pi, if I simplify this, what happens also, see here, pz is equal pz, or we can write here py is equal to 1. It is equal e to the power of z by e to the power of z plus 1. Okay, now this is nothing but py is equal to 1 into e to the power of z plus 1 is equal to e to the power of z. Okay, if I simplify this, finally, if I simplify this, you may get e to the power of z is equal to p of y is equal to 1 minus p of y is equal to 1. Okay, then to develop this model, here what are the variables we have? The question is this. For example, for your data set, you have the x value, you have y value. Then with these x and y values, independent variables and dependent variables, how can you develop this model? That means how can you develop this equation? Okay, then here in this equation, y is there and x is there. That z is nothing but this z is belongs to beta naught and beta 1 x1 and beta 2 x2 according to number of features. Okay, then what you have here, y is there and your x's are also is there in your data set. But what about this beta naught and beta 1, beta 2? These are the coefficients of logistic regression. If you calculate these coefficients of logistic regression and substitute in this equation so that you can develop a model or a equation, mathematical model for logistic regression. How can you estimate these parameters is the question. How can you estimate this beta naught and beta 1 and beta 2 is the question. Are you clear my point? Then in that case, what we are going to do here, once you say this, once you see here, log of, if I apply the log in both sides, log of this one and log of this one. Now what happens? Log of this and log of e to the power of z. What you may get? Log of e to the power of z is equal to z. Okay. Log of this is equal to this one. Are you clear my point? Then what is the Z value? Z value is nothing but this we call as logic. This we call as odds. This we call as odds. Okay. After simplifying this equation, this equation, what do you make it once you see this? What purpose we are simplifying once check? We are simplifying this equation to get what is the beta naught and what is the beta 1. You get the beta 1, beta naught, beta 2 like that. These coefficients are equal to estimate. Okay. If you know these coefficients, I can develop the model. Okay. Now let us take for linear equation yi is equal to beta naught plus beta 1 x1 epsilon. Epsilon is the random error. Okay. Now, if I calculate this error, what do you may get here? If I take yi is equal to 1 minus beta naught, beta 1, x1, you may get here. Okay, are you clear my point? Then y is equal to 0. In that case, 0 minus beta naught, beta 1, you may get here. Okay, with this, what I'm doing here, I'm going to simplify that equation. That what you may get, finally, you may get like this. Final point is what exactly we want to do here is actually here this py value, we calculated this for y is equal to 1. But what are the values you have? Y is equal to 1 is there, y is equal to 0 is there. In that case, I'm going to develop a prototype equation that is P of yi is equal to, this is nothing but pi z. This is pi z yi. Okay, this is positive and its negative is 1 minus pi of z 1 minus yi. This equation. This I'm going to get it. Okay. Finally, here, what is the z value? Z is nothing but beta naught, beta 1 x1, beta 2 x2, beta n xn. This is the z value. Now, your equation, initially what is that? P of yi. P of yi in the sense, if I apply yi is equal to 1, 2, 3 like that, you may get P of y1, y2, y3 like that. Now, finally, what is your z value? Z value is this. And what are the variables here? Here, x is already is there, independent variable. And beta naught, beta 1, beta 2 are the variables. Okay. That's why what I'm doing here, after simplifying this, I'm going to differentiate this equation with respect to the beta naught and beta 1. Okay. I'm going to differentiate. Why I'm going to differentiate this? Why? Because actually there is a logic behind this. One logic is ordinary least squares method. Ordinary least squares method in the sense whatever error you have, that error should be minimum. When it is possible in this is there is a y cap and yi. If this is the minimum, this is a minimum in the sense when it is going to minimum, it is depends on this yi is the actual value. This y cap is the predicted value. This predicted value is depends on beta naught, beta 1, something else. Okay. If beta naught and beta 1, this error should be minimum in the sense that should be the minimum value for this beta naught, beta 1. That's why we are going to differentiate with respect to beta naught. We are going to differentiate with respect to beta 1. That's why the same equation, I differentiated with respect to beta naught. We got one equation. And I differentiated with respect to beta 1. We got one more equation. Are you clear my point? That means two equations are there, two unknowns are there. What are the two unknowns? Here two unknowns are beta naught and beta 1. Okay. If I solve these two equations, I'll get beta naught and beta 1. If you know the beta naught and beta 1, directly you can develop a logistic regression equation. Are you clear my point? I can develop the logistic regression model. This is a mathematical model behind the logistic model. Are you clear my point what I'm saying? Actually, logistic regression, that means P of y is equal to 1 by 1 plus e to the power of minus z. Minus z is the beta 1, beta naught, beta 1, x like that. This, if you know the beta naught, if you know the beta 1, you have the equation. That is nothing but your model. Okay, the same logic, same mathematical logic I'm going to apply on real world applications. Once you see here one simple example I'm going to explain, then I'll take one case study. Okay. Then take this. Let us take this is one small example. Predict whether a patient has a cancer based on feature like tumor size. What do you mean that? What is the data set now? You have a data set like this. You have a data set like this. You have a tumor size. Tumor size is this. And whether is output is output, let us say y. This is x value. X value is the tumor size. Y value is the output. Now your tumor size is something and it is a positive. Is a patient have a cancer? Your tumor size is something, it has no cancer. That means negative. And according to the tumor size, it is going to says that whether it is a positive and negative. Okay. But if I develop a relationship between these two, what do you make it? It is nothing but simply you make it like this. Y is equal to beta naught. Beta naught is the intercept and beta 1 into tumor size. Are you clear my point? You may get like this. This is the equation you will get it. But with this equation, you may get the y value. Y value in between 0 to 1. You may get y value in between 0 to 1. But you may not get y value as 1 or 0. Are you clear my point? Are you clear my point? With this linear regression equation, I'm going to get y is in between 0 to 1, but I may not get in either 0 or 1. If you know the 0 or 1 only, you can say that whether he is under cancer or not. Are you clear my point? That's why once you see here how I'm going to solve this. Let us say my linear equation is this. Y is equal to beta naught and beta naught plus beta 1 plus tumor size. With this, I'm not going to solve. That's why whatever results you got it here, Z or Y, whatever the value you got it here, I'm applying a sigmoidal function on this. This Y I'll take here 1 by 1 plus e to the power of plus e to the power of minus Y. If I apply this sigmoidal function, it will give you either 0 or 1. Any value if you give, it may give you 0 or 1. If you know the 0 or 1, you can find it. Find out. Are you clear my point? This we call as sigmoid transformation. It is a small example I told you. The same logic we are going to apply for big things. Now one point is very clear. Here, your p-value will give either 0 or 1. But this p-value will not give a number in between 0 to 1 or more than 1 like that. If you give a number, that process, that function we call as a regression. Okay. The model which gives a number, that is a regression. The model which gives a label, that gives a classification. This point you please very clear. That's why I'm going to use this logistic regression. For example, if you stop at this place, you may get the number. This is a logistic regression. This largest regression value, I applied sigmoid function. I got 1, 0 or 1. These are the names of the classes. That's why I'm going to assign a class. That's why I'm going to call this as a classification problem. Okay. That's why logistic regression I'm going to use for classification problem. Okay. This is one small example. Now we have one more model I want to discuss. What is the mathematical model behind this? Once you see here. Here also once you see here. How I'm going to use this Bayes classifier. According to Bayes classifier, this is a mathematical equation, probability. One more point also, you please remember, while we are going for probability in the sense, you are going to solve or you are going to predict using the probability concept in the sense, there is a uncertainty in the problem. This point you please keep in your mind. In your problem, there is one uncertainty. In that case, uncertainty problems we are going to solve by using probability. We are using probability even in logistic regression. Why? Because if I got y is equal to 0.2 something else, I am unable to say that whether it is false under cancer or not. That's why that is uncertainty. That's why in that case, to solve this uncertainty, we are using the mathematical concept of probability. Okay, here also I'm using mathematical concept that is nothing but conditional probability. We are using this conditional probability. Here, once you see here, this is a posterior probability. Here, this is a class. Actually, what we have here, your data set is like this. Now, this is X value and this is a C. C is nothing but a Y value. This Y is representing class. Okay, class A or class B or falls under cancer, not in cancer like that. This is a feature. Okay, now the probability of cancer class given X is equal to probability of class given X is equal to probability of X with respect to given class into probability of class by probability of this. This we call as likelihood, and this we call as probability of class. This we call as the prior probability. This we call as posterior probability. Okay. Now with this, okay, this is the logic behind this. Then where exactly this probability we are going to use here? That is a question. Here, where if there is a this conditional probability we are using, then we have in real world, there we have two types of events. One event is independent event. In independent event, there is no need to use the probability. This point you please keep in mind. In case of second point is dependent, not probability, conditional probability. Then in second event is dependent event. Independent event, we are not using conditional probability. Dependent event, we compulsory you have to use the conditional probability. For example, one example I'll tell you the dependent event. Once you see here, if there is a bag with two, three white coins, two black coins, if I taken here one coin from this and if this falls only, I'll take the probability of B given A. That's why there is a condition for that. The probability of B given A or probability of A given B. It is possible when there is a events or depends on each other. Okay, that you have to keep in your mind. Now, what we are going to do here, actually, the probability of B given A is equal to probability of A intersection B by probability of B. Okay, and one more is the probability of A given B is equal to probability of A B intersection A by P A. If I do like this, what happens? Now, what there be you may get two equations. Now, this is probability of A given B into probability of, but finally, you may get this equation. This is a conditional probability. Okay, this is the conditional probability, you may get it. Here, this we call as posterior probability. This we call as priori probability. And this we call as probability of class. And this we call as likelihood. This is a likelihood. Okay. Now, this is a mathematical version. This is a mathematical version. Now, how we are going to apply this mathematics in our real world problem that I'm going to discuss now. Now, once you see here, let us take here, you have a data set like this. And you have a data set and you have, these are the features. This is x1 and this is x2 and this is x3 and this is, then we have the a class. That class is y, let us take. This is x4. Now your data set is x1, x2, x3, xn. This is the class. Now what I'm going to do here, what I want to calculate here, the class, the probability of class, getting yes class or no class or positive class or negative class, any class. Let us take, if I want to know the field class, let us take probability of field class. The given features are this. Let us take given in the sense x1, x2, x3 like that. This is the probability of y class given x1, x2, xn. It is nothing but, according to conditional probability, it is nothing but the probability of x1 given y, probability of x2 given y, probability of xn given y into probability of class by the priori probability. Are you clear my point? This is a priori probability and this is a posterior probability and this is a class probability. This is a likelihood. Are you clear my point? It is nothing but the whatever the mathematical model is there that I'm applying on data set. Are you clear my point? What I'm saying here, y is the label and these are the features. I'm going to calculate the probability of positive corona for given these values, these features. If I want to calculate like this, you have a probability of this and it is equal to x1y, x2y like this. Okay, this is the likelihood. This is a probability of class. This is a periodic class. Now, the same logic, if I simplify this, you may get like this. Finally, you may get py into this is nothing but sigma, and all these are the multiplies. That's why pi I is equal to 1 to n p x I y. This you may get here. Okay. Finally, your equation looks like this. Okay. From these, if there is a yes or no, how many classes are there? Let us take. Let us take in your y, then we have two classes. For two classes, you have to calculate. Let us take positive corona is there, negative corona is there. For positive corona, you have to calculate this probability, and negative corona, you have to calculate the probability. Between these two, which is higher, that value will give, you have to give a decision on that. According to the maximum value of these two, you have to give a decision on that. Okay, I'll take one small example on this, how we are going to apply on one logic. Once you see this, mathematical model is very important. Without knowing, without discussing mathematical model, simply go for only programming in the sense, it is a meaningless. Why? Because being a computer science graduate, we should be in the mathematics model. Okay, I'll take one example on this. Let us take here. I have a data set like this. I have a previous patient's data set like this. These are the previous patients. One, two, three, like that. 8 members patients are there. Then we have the test chills is yes, yes, like that. No, no, like that. Runny nose is this is a test. Test runny nose is no, yes, like that. And mind something, something is there. Then fever is yes, no, something, something is there. Whether is attacked with the flu or not, is attacked with some virus or not. No in the sense not attacked. Y in the sense attacked. This is the database. Now, what is my question now? My question is, for example, one patient, he had the chills as yes, and runny nose as no, and headache is mild, and fever is Y. In that case, whether is falls under flu or not, whether this patient is suffering with the flu or not, that you have to find it. Okay. Now, in that case, I already told you this. What do you mean that? Probability of simple logic you have to apply here. Here, what is the now what do you require? You require the probability of flu. Okay, probability of flu. How what are the classes you have? Two classes you have. One class is no, one class is yes. That's why probability of class no. First of all, let us take yes. Initially, you take yes. Given chill is equal to y, and runny nose is equal to no, and headache is equal to mild, fever is equal to y. This you have to calculate. It's nothing but conditional probability. Again, you have to calculate the probability of no flu given chill is equal to y and runny nose is equal to no, headache is equal to mild, fever is equal to y. This is nothing but it's not, it is like conditional probability only. This is nothing but a posterior probability. This is the posterior probability. You have to calculate this value and you have to calculate this value. Okay. This value you have to calculate this value. Whichever is higher, for example, if this is higher, this person is suffering with the flu. And if this is higher, this person is not suffering with the flu. That's all. It's very simple. That's why, how can you got this? How can you, for example, if I say this equation, let us take now P probability of y given chill is equal to y and something something is there. It is nothing but probability of chill is equal to y. Okay, with and given y in the sense flu is y, then probability of then running nose is equal to null no n, and given y probability of headache is equal to mild, probable given y, probability of fever is equal to y given y into probability of that class. Probability of that class is y by that is a constant. You may not calculate like this. Are you clear my point? Denominator is a constant. It may not influence on effect on your result. Okay, are you clear my point? Then like that you have to calculate for now. Same thing I'm going to calculate now. Once you see here, once you see this, I'll explain clearly once you see this. Let us take here, I'm going to calculate my P of flu is Y. Flu is Y in the sense, yes, flu is the patient suffering with the flu. What is the probability? That means how many patients are there here? 8 patients are there. How many yes are there in the flu? One, two, three, four, five. 5 by 8. It may gives you 0.625. This is nothing but this one. Okay, are you clear my point? Then, if I want to calculate probability of chill is equal to y, why? Because you require. Then, given flu is equal to y. That chill is y and flu is y. Once you see here, how many are there? Chill is y and flu is y. It is wrong. Then chill is y and flu is y. That means this is 1. This is 1. And chill is y and flu is y. This is 2. Then chill is y and flu is y. This is 3. Okay. How many? What is the value? 3y. And what is the flu y? Flu y's are how many flu y's are there? 1, 2, 3, 4, 5. 3 by 5. It is nothing but zero point 0.6. Like that, you have to calculate all values. Simply, you have to substitute these values in the equation. In the equation like this. In this equation. Are you clear my point? Now you may get, finally, what do you make it once you see here? Once you see here, if I calculate no also, you have to calculate. The same logic you have to apply for no. Okay. Whatever the classes are there, for all classes, you have to calculate the probability. Okay. Now, finally, what do you make it? Now, you make it here for no, for yes, you have 0.06006, for no 0.0185. That patient which is suffering with chill something is there now. That patient, this is a higher value. That's why is not affected the flu. Is not affected flu. Okay. Like this, you are going to take you are going to give a label to the object or label to the patient. What is the label? There is no flu. There is no flu is the label. To whom you are giving? You are giving on a patient. Are you clear? This is nothing but the classification problem. This problem we can apply on all medical problems. Okay, this is not only medical problems, we can use this same concept for all. Are you clear my point? Then let us take. Yeah. Now we have discussed within this less time. I'm going to move fast. We have only 10 minutes time. Here, let us take how you are going to evaluate the classification models in spell. You can calculate this and you can calculate the precision and you can calculate the recall and F1 score. Mostly in our case studies, we calculated F1 score only and we calculated ROC spell receiver operating characteristic, that is ROC, and also PR also is there. PR is nothing but precision recall maps also we have done. All these things I'll show it. Okay. Now, now with this, within 10 minutes, I'm going to move one case study on the first one and second one. Once you see here. Once you see here, is it visible, sir?
Yes, sir. Yes, sir.
Now here, I'm using the breast cancer detection here by using here we have taken The data set is like this. Here, once you see this, these are the these are the libraries we are going to import. Or the import
The
numpy,
data set is not showing, sir.
data set already be executed, madam. I
Okay.
already executed the notebook. I'm going to show it.
Okay, sir.
The Jupyter notebook I'm showing. Directly, I have taken data set that is a breast cancer data set.
Yes, sir.
Data
Now the slide
set.
is F1 score
Is it visible, madam?
visible, sir.
Ah,
F1 score area under receiver operating characteristics curves.
that is over now. That
Now
is
on the slide is not moving, sir. Just
okay. Okay, I'll show that. Now it's okay, madam. Madam, now it is
yeah.
showing
Yes,
that.
yes, sir. Yes, sir. Yes,
Right.
sir.
Now here actually we have implemented that the best concept by using Navi based algorithm. Now also see here these are the libraries imported. Import in NumPy, Pandas, as well. This C1 and Matplotlib, and I'm going to load the dataset, that breast cancer dataset. If I execute this, you can execute here. Actually, by sharing, I unable to execute now. Once you see this, here I read this dataset, and this is a head, spell top five records it is going to see. Here there we have the features like this: mean radius, mean texture, mean perimeter, mean area. All these are the features: x1, x2, x3, x4, like that. This diagnosis is there. No, this we call it as a label. This is a y. Okay. Now tail, bottom five records it may display. Data dot shape, it may gives you the dimension of the data set. 569 records we have taken, six features. Now data dot information, it may gives you what is the mean of what are the data types, all these things it may gives you. If I write here data dot description, it may gives you the standard deviation, the mean, more like that it may gives. But here I have not written. Now here I developed the histogram, but here in this show I unable to execute it. I'm not able to execute it. It is not executing now. That's why it is not visible for you. Now here in diagnosis, what are the records we have that we may display it? One, we have 357 records. Zero, you have 212 records. I designed the heat map. Why? Because there we have six features are there. No? Among these six features, if there is very high correlated features are there, that I'm going to drop now. But here I have not performed the dimensional reduction here. Just I have not performed even data preprocessing also. Simply I executed directly. I here this is a data set. This data set I divided into independent variables and dependent variables. My x, capital X, is the independent variable. My small y is a dependent variable. But this division of the data set into independent and dependent variable, the code is this: capital X is equal data into the features, dot values, and y, small y, data is diagnosis. That means label. Now I'm going to split the data set. Now I'm dividing the dataset into two parts: training dataset and testing dataset, with 0.2 and 20 percentage and 80 percentage of dataset. Okay, I'm using this dataset. This is a code which we imported from the sklearn. Now I'm going to import the base classifier from sklearn, and I created one class for that. That is a Gaussian NB, that we also call as base nest pair. We have Gaussian NB. Okay, that class I created, and I'm going to fit this model. I'm going to fit this model, and I'll calculate that y prediction. That for that, all whatever the parameters you want to predict from the model, that you have to import the metrics from the sklearn, from sklearn dot matrix, import the accuracy measures and confusion matrix, accuracy, precision, recall, all these things you may get it. For this, in this case, I got here my accuracy score is 92.11%. Even the actually why? Because we have taken only 590 records only. That's why we got that much of higher level. Now I have tested with the same data set. That's why we got a very high value, I think. Now here F1 square you got 0.94. It is also good comparatively. If I see all these things, it is good model. Then this is an application to predict breast cancer using Bayes algorithm. Okay. Now I'll stop this and I'll go to the next one. One more. One more. Once you see here, this is we use the here logistic regression for diabetics prediction. In diabetics, we have taken diabet2.csv data set. There we have many data sets we have. It is available in the Google and Kaggle. That's why we have taken diabetic 2.csv. Here, spell, read, diabet, all this executable only. Here we have taken the features of glucose bed, pressure, skin thickness, insulin, BMI, all these things, function, that age, and the outcome is 0 or 1. Outcome is 0 or 1 in the sense here dependent variable is outcome, that is y. Okay, 1 is suffered with the diabetics, 0 is not suffered with the diabetics. Okay, these are the features, these are the class. Now for this, here this information, DF description, all these things you may get. Now, this is a graph we drawn for age with respect to the glucose. Age with respect to the glucose. This is a graph to that means, and also we drawn pair plot. With using pair plot, you can find it. What is the correlation between the features? Okay, according to the intensity of correlation between the features. We can use heat map also. Then with this also you can find it. Once you see here the diagonal, once you see this diagonal is high correlated. Now once I am going to apply the logistic regression and I'm going to calculate the confusion matrix, then accuracy, all these things I imported from the sklearn dot matrix. It is a library for all parameters for classifications. And these are the things we calculated. Now I'm going to the spell logistic regression. I already discussed what is this and how it is. We already discussed in this theory, and we imported the logistic regression from sklearn, and we trained the model, fit the model.fit. Model.fit is nothing but this command will give you. It is a you are going to implement logistic regression on the x train and y train. Okay. Now you have to test this model with the x test and you have to see the y value. That's why this we call as supervised learning. Here we calculated the confusion matrix for my entire that. Now here my accuracy is 0.79 only. Okay. Why? Because here data set is very high and also we have not performed the data pre-processing and also dimensional detection. One thing I can say that if you perform only the logic is if there is a pure data set is here, you may get the good results. If the data set is in the noisy something else, you may not get the good results. Okay, I think this is time given to me. With this, we this is a confusion matrix. All these things spell. This is a model related to diabetics prediction. I think we have discussed the prediction models. Two prediction models we have discussed. One is logistic regression prediction model and the Bayes theorem prediction model we have discussed. Okay. the usage, all these things we have discussed. And any queries you can ask me. And otherwise, you can post in the chat box. Why? Because I stop here. All of you are tomorrow again. You have to go to the college, right? Okay. Anything else? You please ask me, or you can post here. I'm going to see your. Okay.
Uh,
Thank you, sir. Thank you, Hemant Kumar, sir. Thank you, Madam Lakshmi, Madam.
yeah, thank you, sir. Thank you, sir. Thank you so much, sir, for your valuable words and information. Thank you, sir, for explaining a logistic regression and Bayesian algorithm. Your insights on these statistics and machine learning techniques are appreciated. Logistic regression is a crucial for binary classification and Bayesian methods offer a probabilistic approach to modeling and inference. Thank you, sir. Thank you. Your deep information. We appreciate the time and effort you have put into preparing and delivering this session. Your expertise has made a significant impact on us, sir. Great information, sir. Thank you. By practically, we learn the data set, how to execute useful things, sir. Thank you
Thank you
very
very
much,
much.
sir.
Thank you, Madam. Thank you for your kind opportunities. Thank you.
Thank you, sir. Busy schedule also you are
Nothing,
accepted.
Madam.
We are very
Nothing.
thankful. Behalf of our college also, we are
Thank you, Madam.
thanking you, sir. Yeah, sir, switch on the video, sir. We'll have
Right,
one
Madam.
photo, sir. Yes. All the participants, please switch on your videos. We'll have a photos. All switch on your videos. You can, all participants, can you able to pin to the screen? Is it possible? If you are able to pin to the screen, everyone will visible. Please try to pin yourself. All please switch on the cameras if possible. Thank you for patience. You are attending regularly. Successfully, we finished our third day.
Thank you, Madam.
Thank you so much, sir.
Really?
Sir, 1 minute, sir. Sir, you are available, sir.
Mine, Madam.
Ah, yes, sir. Okay, sir. Just wait, sir. Wait, sir. Thank you all. Thank you all. Thank you for your cooperation. One minute, sir. Okay, second, sir. Thank you, sir. Thank you. Thank you, everyone.
Thank you, Madam.
Thank you. We'll meet tomorrow. Anyone fill the sheet, please? Yeah? Whoever are not filled the attendance sheet, just fill it. It is going to modify in the website. Attendance should be 80%. At the last day, we are going to conduct the test. It should contain 70% of marks it requires. Any problems, just ping me message. Thank you.